to another video. In fact, it's a very short video where we talk about how to shard a Tenstorrent or TTNN tensor to resolve the shape mismatch or for your requirements. So it depends on you. For optimized computing or parallel computing. So I'm already shard two tensors. Here's how to shard the tensors. The main requirement is to validate the number of shards must less than available cores, number of cores. So here's an example. You have to create shard specification here using this class, then supply the core range or core grid. Here's the pre-built function which available in the common model. You can import so it's hard to because it's hard to create or find the coordinate of cores. So there are pre-built function, as I said, which is named to core range set, which is number of devices. Anyway, it's included in the common model. Import it anyway. Here's already imported. It's so which will simplify the work. Anyway, let's continue. Here's you have to set you have to import the shard specification class, then set the core grid, and the second parameter is the shard shape you want to shard. For my tensor, which is WL, which is density weight about 2560, which is divisible by 1280, which gives 2 cores, available cores. You can print to see how many cores are available. Just print to print mesh device, self mesh device. Then you should know how many cores are available. Anyway, if only fails, or it will be print to you the number available cores. So just edit the shape plus dim to match the available cores. Anyway, you have to set then pass the shard specification variable to the memory config. Also, we have to import all the memory config class. Then it's pretty simple and pretty clear. First parameter we have to strategy or layout. Second, the buffer. There are DRAM and L1. And the third, of course, the shard specification. And that's all. This memory config will pass or supply to the as tensor function or from charge function. Also accepts memory config like this. Also, you can pass it matrix multiplication function, linear function. Also, here's an example, other example here in the cost here. Which is the attention outputs we have already sharded to be 640 years. Yeah. Anyway, the input tensor of okay, the input tensor, yes, attention output, which is attention output. Anyway, here's another example. The memory config supplied to interleave to sharded, which also accepts memory config like this. So that's all. Here's two examples of two types of tensors, which the first have DRAM and the second interleaved as type. So that's all. Let's see it in action. I'm already print, so you can see here the layout of each tensors. So just to validate it by running single command. This command also validates the prefill step, which already compiled. So that's not interesting us here. We just want to know the shape of two tensors, which is projected at summation output and the dense weight tensor. It's sharded as we decide or as we want. Here's the warning: that's not a big problem, or it's does not problem at all. Anyway, I just want to show the shape of our tensors. Here's as you can see here the supplied shape, and for the WL tensor also as we supply. So that's important thing in parallel compute or optimized compute. So sharding tensor is important thing you should know. Also, it's pretty easy and pretty clear, and that's all. These two tensors will supply to the matrix multiplication for the final attention output. Anyway, that's not interesting us in this video. Thanks for watching. See you in another video, and have a nice day.